Hi guys, welcome to our platform. Augustine is my name. I want to welcome you to Chibuzo Math Physics. In this platform, we are dedicated to helping you solving your numericals and other mathematics calculations. So, for the purpose of our topic this morning, I will be taking you through the derivation of the equation of the hyperbola, the equation of the hyperbola. Now, I want to show you something. Hyperbola, you can see in the paper that I am holding, you are going to have a hyperbola opening from the right and opening from the left. So you will have two lines in the Cartesian plane, then you have our hyperbola. So it shows us the directions, that is the hyperbola. So we are going to be deriving the equation of the hyperbola, but first I want to help us understand what actually is a hyperbola. So what is hyperbola? It is a set of all points in a plane such that the difference of its distances from two fixed points is constant. So the distances from two fixed points will be constant. You see, in the Cartesian plane, we have the x and we have the y axis, but the distances between the 2 points will be constants. I will show you why they are constants, how they are constants, and why it is very important to always remember that. The equation is always here, but I am going to clean it up, and we go step by step as I will derive the equation of the hyperbola. Let us get started. Let's clean up this so that we start afresh on deriving the equation of the hyperbola. Just a minute. Okay, so let us get started. We are talking about a hyperbola. And from definition, we have said that it defines the distance, the two fixed distances in a plane. In a plane, you have the y axis and you have the x axis. So we are having the f, which we call the foci. It is called the foci or the focus. Some people call it the focus. Others say that it is the foci. So whatever you call it, but I prefer to call it foci. So the foci will have 2 points, f1 and f2. Now, this 2 point is represented with letter C. So this is C, 0, because it is in the x-axis. So at the origin is 0, but from here is the distance, C, 0, which means we have our C at the foci and we have our C, but because it is on the negative side, this is negative C, 0. That is the first thing you need to do when you are deriving the equation of a hyperbola. Now, we have to sketch our hyperbola. It will look this way. Now, this point here is the vertex or the vertices. We are going to also have the co-vertices because it depends on where the your parabola is opening. It could be opening from sideways, it could be opening sideways, and it could be opening upward or downward. So the distance from here, f1, up to any point in your hyperbola can be connected to your f2, which means this is our d1 and this is our d2. So d1 minus d2 is equals to plus or negative 2a. And that is the constant that we are talking about. Is plus or negative 2a. Plus or negative 2a. I hope you are getting the concept, because we are trying to use this particular Cartesian plane to explain on how to derive the equation of the hyperbola. And with this constant now, we can actually begin our derivation. Let us get started. We know that the distance formula will give us the square root of x1 minus x2 plus y1 minus y2. And all these are squared. This is the distance formula. So applying the distance formula, we are going to use the distance formula, because remember from our definition of what is a hyperbola, we said that it is a set of all points in a plane such that the differences of its distances from 2 points is constant. So we are going to be using the distance formula to derive the equation of a hyperbola. Okay, so now we know that we are having two distances from the x-axis, negative x-axis, to the positive x-axis, and also y, positive y-axis to the negative y-axis. So we are going to use the square root of x minus c squared plus to make it more visible, I hope you can see that, plus y on the y-axis now minus 0 squared, and this will be minus the square root of x plus c squared. But now you can decide, since here we're having positive and negative, remember you have the positive side and the negative side, so you can actually interchange. We can start with positive and negative, so that here you have y minus c and x minus c and x plus c squared plus y minus 0 squared. All this is equals to the constant number that I have already mentioned, which is 2a. So with this, we can rearrange the equation so that we have the square root of x minus c squared plus y squared, because here we have y minus 0, so we have y squared minus the square root of x plus c squared plus y squared. All this is equals to 2a. So we try to bring our constant to this side to enable us to expand this bracket. So we are going to have the square root of x minus c squared plus y squared is equals to 2a. We are bringing this 2a to this side. But now, since we have already taken this square root to this side, the the negative sign changes to positive. So we are going to have plus the square root of x plus c squared plus y squared. Good. So from here, we proceed to the next step. The next step will be we have square root, so we square both sides. We have to square both sides. To square both sides, we are going to have the square root of x minus c squared plus y squared, all this squared is equals to 2a plus the square root of x plus c squared plus y squared, all these squared. So we try to open up, we have x minus c squared plus y squared is equals to 2 by 2 equals 4a squared plus 4a, the root sign of x plus c squared plus y squared. This is just applying binomial so that we are able to open up this bracket. We have applied a little binomial. So now we can try to do a little more of opening the bracket. We have x squared minus 2 xc plus c squared plus y squared. This is equals to 4a squared plus 4a, the root sign of x plus c squared plus y squared. This will give us, because here, remember this is binomial, so here we are supposed to have plus x plus c squared plus y squared, so that you will open up this bracket, you have plus x squared plus 2xc plus c squared. You can get rid of some of this. C squared plus y squared. Now, if you notice, we have x squared, c squared, y squared, x squared, c squared, y squared. So those ones can actually go. You can cancel. So that now we are left with 2x, we are left with 2-2xc is equals to 4a squared plus 4a, root sign of x plus c squared plus y squared plus 2xc. So we take this to this side. This will become minus 2xc minus 2xc is equals to 4a squared plus 4a, the root sign of x plus c squared plus y squared. From here now, can actually do something. So now we have 2 minus 2 minus 2. It will give us, if we bring them together, that will be 4xc minus, we take this 4 to this side to give us minus 4a squared plus, and this is going to be equals to 4a, the root sign of x plus c squared plus y squared. So this is what we have now. Remember, we are trying to derive the standard equation of the hyperbola. The standard equation of the hyperbola that is opening horizontally, because it can open vertically, it can open horizontally. But if it is opening horizontally, our standard equation will be x squared all over a squared minus y squared all over b squared. All this is equals to 1. So this is the standard equation of a hyperbola, and our target is to derive this standard equation. So now, if you notice from our what we have, 4 is common. We have 4ax minus 4a squared is equal to 4a square root of x plus c squared plus y squared. So now we can actually divide all the terms by 4 to enable us get rid of that 4. So we will do this: divide by 4, divide by 4, divide this by 4. So 4, we go with 4, this we go, this we go. But remember, from here, when we were opening this bracket, this will change. Instead of a power this, you remember we have opened the bracket of this. But let us go with this. We are going to have x squared xc minus a squared is equals to a root sign of x plus c squared plus y squared. So what are we going to do from here? We are going to divide, we are going to square both sides as we did before to remove this square root, so that we will have xc minus a squared. All this will be squared. This will give us a, the root sign of x plus c squared plus y squared. We are squaring both sides. And when we square both sides, what do we have? We open, we have x squared, c squared minus 2. Binomial, you have minus 2a power with minus 2a power 4 plus a minute minus 2a squared xc, then minus we have a squared, it will give us a power 4, and this will be equals to a squared. The root sign is still there. The root sign is still there, but remember we have tried to square both sides to get rid of that root sign. So we have x plus c squared plus y squared. But now, since we have a squared, we have a squared, we have a squared, but power 4, we can actually divide everywhere, all the times by a squared, a squared, a squared. So now, a squared, we go with a squared, a squared, we go with a squared, a will remain because we don't have a squared in the denominator, but a squared here we go with a squared, so that we are left with x squared c squared over a squared minus 2xc, because this has cancelled, minus, remember we have a power 4, so we are left with a squared, and this will give us x plus c squared plus y squared. But now we can expand this bracket so that we have x squared c squared over a squared minus 2xc minus a squared will give us x squared plus 2xc plus c squared plus y squared. So now that we have that, you remember, if you notice, we have plus 2xc, we have 2xc. So that can go away, so that we have x squared c squared over a squared. This will be minus a squared is equals to x squared plus c squared plus y squared. So from here, we proceed. We have not yet arrived at the answer. Our purpose is to derive the standard equation of a hyperbola that is opening horizontally. That is our aim. And we have not yet arrived at that standard form of that equation. So we need to continue. What we have is x squared c squared all over a squared minus a squared is equals to x squared plus c squared plus y squared. But if you notice, we have x squared, we have x squared this side. We can actually bring all the like terms together so that you have x squared c squared over a squared minus x squared. This will give you c squared plus y squared. Now this will go this side to become positive a squared. Now remember, from what we have here, you can actually look at the terms so that if we look at them, we can actually factor x squared out so that we have x c squared over a squared. And this is just the same like 1 will give us equals to c squared plus y squared plus a squared. Now, we can, to have c and a together, we know that from the Pythagorean theorem, c squared is equals to a squared plus b squared. So b squared will be equals to c squared minus a squared. So this is our b squared from the Pythagorean theorem. So to have c minus a on one term, you remember what I told you from the beginning, be careful with the signs, Here we have signs, we interchange the signs. Sorry for that. Here we're supposed to have positive A, so that you will be left with positive. So that here, what we are going to have here is positive. If you take it to this side, it will become negative. We always need to pay attention, although sometimes this happen, but we always have to pay attention with these small errors so that we will not have issues in our final answers and results. So now that we have this, it means that this is negative A, and if that is negative, you will be left with x squared all over c squared over over a squared. This can be written as minus a instead of 1 minus a squared. And this is equals to, we can actually bring this to this side, it will be negative y squared, so that we have c squared minus a squared. What we are doing now, we are trying to apply the Pythagorean theorem that says that c squared minus a squared is equals to b squared. And from here, we know that we already have c squared minus a squared. So the whole of this is b squared, and the whole of this is equals to b squared. So that now you will have x squared into b squared all over a squared, of course, minus y squared is equals to b squared. Are we together? Is equals to b squared. So now we have our x squared b squared over a squared minus y squared is equals to b squared. We can actually divide all the times by b squared, by b squared, by b squared in order to get rid of the b squared. So that b squared will go with b squared, we are left with y squared over b squared. This will divide to give us 1. If we notice, what are we left with? X squared all over x squared all over a squared minus y squared all over b squared. And this is equals to 1, which is the standard equation of a hyperbola opening horizontally. The standard form of the horizontal hyperbola. I hope you enjoyed the video, and I hope you have enjoyed the derivation. It is all about following the steps. It is the concept. It is not about cramming it. And I will hope to see you in our next video. I will be deriving the equation of the parabola and the equation of an ellipse. And at the end of the video, I think you will find it helpful and enjoyable, and you will like more analytical geometry, because this is analytical geometry work, and it always disturbs students on how to derive this equation, because most of the time we mix up with signs, and I think that is normal, but we just need to pay attention on those common rules so that we are able to arrive at the derivation of the equation. See you in our next video. God bless you.